Hey guys, welcome to Great Learning. Now, autocorrelation, as you can read from the screen right now, is actually a very important concept that governs the entire world of data analysis and to a certain extent machine learning and of course data science as well. Now, you might have used autocorrelation before, or you definitely have heard of correlation, and you might have practically used it, just that you wouldn't know that it is called as correlation, and this is what happens, when you are actually using the term in the information technology world. But one thing you must understand at this moment of time is that autocorrelation finds its importance in all of the domains wherever you have certain metrics through which you can actually perform some assessment and use that assessment to perform a data-driven, to maybe drive a solution, right? Which is again based on the data. Now, as you can see, when I say data analysis, when I say correlation, you have to understand that this is not very domain specific. I'm not saying that correlation is going to always be used only in a finance industry, or it's going to be only ever used in one certain industry, right? No way, because the domain, the terms, the way it works, as you'll realize throughout this course, will open up to the fact that this is a concept which is very widely used, and this makes it extremely important for you guys as learners to understand this completely, right? So guys, I present to you this course on autocorrelation. We here at Great Learning made sure to have a lot of theoretical learning and of course give you guys a practical look at what we're discussing as well, right? So guys, let's get started with this course without any further ado. My name is Anirudh Rao. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments. And here's the agenda for this course. Well, to talk about the agenda for this course, autocorrelation, we're gonna have to start this out by going right back to the basics, by going right back to the fundamentals and starting our learning by understanding first of all, what is correlation, right? Now, once you understand what correlation is and once you get a fit of the concept, once you know what's going on there, then it becomes very easily for me to convey to you guys and tell you guys about what autocorrelation is and a lot more, right? So we're gonna start this out by understanding what correlation is. I'm going to be giving you guys an ample amount of examples, so do not worry. And then we're going to be diving right into understanding what autocorrelation is. Now, once you start getting curious about autocorrelation and once we start getting this build up going, you'll very much be interested to know more in depth about the same. So that is where we'll actually perform a deep dive into autocorrelation and make sure that you guys have very strong foundations through which you can build upon later, right? Now, after understanding autocorrelation to a good amount of detail, there will come a point where you must say, hey, okay, so if this is autocorrelation and if I have to test for autocorrelation, how do I do it? Well, we're going to discuss a section there as well, right? So you can see the section which is how to test for autocorrelation. We are going to make sure that, you understand how not only you can work with autocorrelation, but also test for autocorrelation. And at the end, we are going to be discussing the applications of autocorrelation as well. Now, after this application, whatever you're seeing on the agenda right now is the section wherein we will be discussing the theoretical section, but I also want to mention at this moment of time that at the end of applications, we are also going to be taking a practical look at understanding autocorrelation as well, right? If not, you're going to definitely get a sense of way better sense in terms of how correlation works. Why is it so important? Not only just through theoretical learning, but through the demonstration and Python as well, right? So guys, I hope the course agenda is clear to all of you all. On that note, I think we can proceed to the first item on the agenda. Alright guys, so to come to the first item on the agenda, what is correlation? Now, correlation, the answer actually sort of lies in the name itself. Now, when you say, hey, relation, right? Now, you can say, I am related to this person, or especially you might have seen, whenever someone maybe starts up their own company, they're called as the founder, but when they try to bring in more people onto the board of directors or something, then a person can be elevated to the status of a co-founder. Now think about relation, correlation, right? Now, when you say something is correlated to another, you're trying to basically tell that, hey, there is some structure which is giving resemblance, or which is basically giving some sort of the same meaning in a specific application with two entities at hand. Now, with respect to correlation, usually what we do, since we're discussing about data analysis, is for the fact that we'll have a lot of rows and columns of data, right? Now, when each of these rows and columns of data, when you have columns especially, columns usually contain one type of data, right? Now, in the demo that we're going to be discussing, we're going to be trying to understand how we can go on to predict if a person has diabetes or not. And one thing you have to understand about diabetes is there are many factors which is going to lead to it, right? There are several variables like blood pressure, insulin, body mass index, and so many things. So how do you know which variable is related to another, right? Now, an increase in your blood sugar may actually give rise to an increase in your blood pressure as well, right? Now, you wouldn't, you or me as people, I am a data science expert and you're a learner in the domain. So we are not healthcare experts and we might not know it. But guess what? If we do have very accurate data, and if we have a large quantity and good quality of data, we can actually plot the relationship that exists between these two variables. Now, I know you're saying this at the moment, saying, hey, there might not be any relation at all. Why are we trying to find some relationship between these variables? You're absolutely right. When you look at something with the naked eye, there's a very good chance that, you might not be able to figure out that there is a relationship that exists. There is a pattern that you can look at. There is something that you can perform assessment. But as always, in the domain of data science and data analytics, the second you start diving into the depth of a concept, that is when you open up a whole new can of worms, right? And this is the good can of worms that we're talking about. So that is to give you a quick idea about what correlation is. But correlation, when we apply it, basically we call it as correlation analysis. Now, correlation analysis is a very important part in terms of statistics, because here we use it to actually perform certain evaluations to understand not just if a relationship exists between two or more variables, but at the same time we try to see how strong or how weak. We're trying to assess the level of relationship. We're trying to assess the strength in the relationship between these two numerically measured variables, and in many cases the data is usually continuous in nature. Right now, you should know that data comes in various forms: discrete data, continuous data, uniform data, binary data. There's like a million forms of data around us, right? Now, as I just told you, it's not always about showing if there is any kind of relationship that exists, but it is also equally important to show how strong this relationship is, right? Now, when you say correlation, when you say, hey, something is related to something else, there is usually three situations, right? When you say something is positively correlated to something, it means that as one increases, the other one will also increase. I'll give you a simple example. Now, if you take a cup and maybe fill it up with ice or something like that, and as and when time passes, as and when time increases, right, from the point you put the ice to or later on, the increase in time will also, lead to increase in the temperature, because you've put it in your room or you've put it in your kitchen or somewhere where it's pretty hot, and we all know that ice melts at 0 degrees, right? So all in all, the increase in temperature is basically going to, at the end of the day, increase the ice. Ice, you would have seen that it's very dense, but as soon as it starts becoming water, there is a lot more of it, right? So when one changes, the other one changes. Now, negative correlation is very easy to explain. Just think about the fact that you just fueled up your car or your bike or something to full tank, and you start riding it, right? Maybe you're going on a tour with your friends or family or whatever. Now, once you start riding it, you realize what happens is that as and when your distance increases, what happens to the fuel? The fuel decreases, right? So the fuel decreasing is proportional to your distance increasing. Now, that is a negative correlation that happens. If and as and when the fuel decreases, that is when your distance increases, right? Now, you might say, hey, I'm going to just stand there and idle and I'm just going to keep giving it throttle. That is still fuel being wasted, right? Yes, but at the end of the day, that is not the discussion. The discussion here is between distance and fuel. When you directly put a comparison and say, what is the correlation that exists between the level of fuel in my tank versus the level of distance I go, that is when you'll understand that there is a negative correlation. Now, again, I repeat, why negative? Because of the fact that one decrease decreases, the other one increases. If one increases, the other one can decrease in multiple other examples, as you can see as well, right? Now, when you have this kind of a relationship that we have established, one really important thing you have to have in mind is, well, we can have any value, right? Now, you can say that one variable has a correlation of another variable with respect to 65,000 lakhs. Does that make sense? Well, what are you comparing it to? What is your norm that you're setting it at, right? So whenever we discuss correlation, we try to always have the values in one particular range. Anytime we talk about correlation, the values usually go from -1 to +1. When the value is at 0, it means that there is neutral relationship between two variables. When the value goes from 0 to +1, it means there is positive correlation between these two units that we're discussing. But when the value goes from 0 towards -1, it can be -0.05. That still indicates a certain amount of negative correlation there, right? So when you try to compare how strong or how weak the relationship is, since it does not have any direct significance apart from the discussion at hand, we have to normalize these entire values to the range of -1 to +1. And now you know what happens at -1, what happens at 0, and what happens at 1 as well, right? So as you can already probably tell, correlation is a really fascinating concept, and to put a relationship out numerically and to get your machine learning algorithms or your models to understand that this relationship exists and to use it as leverage to become more efficient in terms of the ML process or whatever it is that we're discussing, at the end of the day, you have to understand that this is a very, not just an interesting concept, but yet at the same time, it has a very powerful outcome as well. Right? Now, again, to give you a couple of examples to make sure you understand correlation, when we're discussing the diabetes case, now we're going to take a look at this practically, but here's a question to you. There are many factors that can lead to the cause of diabetes. It can be age, it can be your body mass index, it can be the amount of food you eat, the blood sugar level, your blood pressure level. There's like so many things, even hereditary, right? It's been proved that there's a very good chance you might get diabetes if it's in your bloodline, something like that. So how do you understand? We know the outcome here. The outcome is either yes to diabetes or no to diabetes. But how sure are you? What is the relationship that you can draw to say that, hey, age has this much of say in diabetes. Body mass index has this much amount of importance in diabetes. Blood pressure has so and so level of significance in diabetes. Now you see those three very different terms that I used. That is where, when you ask questions such as that, correlation is where your answer lies in, right? Now I'll give you another fantastic example that you definitely can relate to. I'm very sure some of you all watching this course, you might have bought a new house, you might have moved into a new house, or you're probably buying new plots, getting something constructed or something like that. You have to understand that price of the house or price of plots, especially here, here in India, varies very much with respect to the area and the locality that you're a part of. Right now, in whichever city that you're a part of, for example, here in Bengaluru, we have multiple places which are considered as posh. Now, when you say posh, basically it means that there's so many amenities and the area is so, lively and pumping with people that, of course, if more and more people want to come into that area and maybe get into restaurants, pubs, or whatever it is, that area will actually be a lot more pricier, right? So is it just the locality and the area that will determine the entire price of your house? Don't you think age of the house that you're about to buy matters? The convenience, how far away it is, for example, from the airport, from the nearest school. So we have a lot to see, as you can understand. So at this moment of time, you can find each of these things which have a small say in the solution. You can actually find out to what level of significance do they have a paradigm shift on your solution, right? How cool is something like this? One more example. Think about predicting tomorrow's weather. Of course, predicting tomorrow's weather is very easy. All you have to do is pick up your phone, say, hey Google, hey Alexa, hey Siri, what is the weather like tomorrow morning? Boom, you're done. You have details about tomorrow's weather. If you want like tomorrow's, the entire next month's weather, next year's weather, everything is at hand without much effort. Now, do you know what goes on into actually determining the weather, right? If I have to say, hey, it might rain tomorrow, there's a lot of things that's going to, that has to happen before it can start raining. Think about clouds. Think about the precipitation factor. Even pollution, right? If there's more pollution, usually there is less rain. If there's less pollution, there's usually a good amount of rain as well. See, negative correlation. Now, you can actually map in any situation that you can think of in real life when you start becoming the data analyst that you're hoping to work towards. Whenever you learn technical concepts such as these, and after finishing this course, once you go over and you're living your daily life, you'll figure out that you will actually tend to pick up more of correlation in real life as well, and that is how you actually build up. That is how you go on to your addition of the concepts that you take away from here. Right now, this is one such concept wherein as soon as you walk out, as soon as you finish this course, get your certificate, and you're done, you will have the knowledge to completely assess everything around you and to figure out what level of correlation exists in the real life as well, right? So that has to be a really cool side takeaway as well. Now, in the previous section, we had a chance to understand correlation to a good amount of depth, right? I told you what correlation is, I told you where it is used, I told you how it is used, I gave you the range that exists for correlation, I told you its importance as well. Now that we are done with that, let us actually dive right into the heart of the topic, where we're going to be having an introduction to understanding autocorrelation. Now, autocorrelation is very similar to correlation. Here we're just trying to find out the degree of similarity that exists between an observation at one point of time and maybe an observation at a previous point of time, or maybe even in certain intervals as well. Now, when you take this entire statement that I just said and you have to understand it mathematically, this is exactly what autocorrelation is, right? Now, autocorrelation is very similar to correlation, as I just mentioned, but here we'll have two different time series in it, wherein we'll use the same time series twice. Once in the original time series that it exists, the other one where it has one or more time periods attached to it. Now, when you start adding time to an observation, you can figure out on your own that there is some correlation that you can pick up from that as well. Once you understand how something changes with respect to time, and you want to track it, and you want to do, when you want to have data-driven solutions based upon that, you're going to basically require two things. One, the observation, which is exactly what you want to do, and a lot of other observations which occur at different points of time. Now, to give you a quick example, when during way back in the 19th, 18th century, and even today, how do you think astronomers actually find out the stars which are billions and billions of kilometers away from us, or light years away from us, right? So you basically take a snapshot of the sky at one moment of time, and you take another time period of it, and you take another picture of it. That's when you realize how things are moving. If you guys are astrophysics buffs like me, you'll figure out this is exactly how they figured out that black holes really exist in today's world, right? Because you find some abnormalities in gravitational forces around certain stars and all of that, and that's when they realize that hey, something is there. And again, as you can see, anything in real life can quickly be mapped to the concept of correlation and autocorrelation as well. Now, once you are understanding correlation with respect to time, you will also have something called codependence. Now, I'm going to give you an example. If, let's just say, there is a situation where it is raining really hard in Bangalore today, well, if it is raining really hard today, there's a very good chance, there's a good chance that I might guess that tomorrow it will rain as well, right? So, there's a good chance it will rain tomorrow if it's raining today. But what are the chances that it will rain heavily tomorrow if it is clear today? That is not very clear, right? Now that we actually split up our solution into two different time zones, today and tomorrow, once you figure out that there is something you can start with today, tomorrow becomes very clear. But if you have to say that tomorrow it will rain, considering today is the brightest, hottest, sunniest day of the year, it will probably not make so much sense. So when you have to find and build the dependencies there, once you have to understand the relationships that exist there, this is where autocorrelation plays a very important picture. Now, the weather example is absolutely beautiful. Let me give you one more example, especially when it comes to making investments, right? So, whenever you talk about autocorrelation here, basically in the case of investment, we talk about autocorrelation in terms of its returns. So whenever you're trying to invest something, you have to understand that a stock's autocorrelation of returns might be, if it is very substantial, if the returns are huge, it means that there's a very good chance if the stock price went up today,
that it will go up tomorrow as well, right? There is this dependency that's happening. If your stock rises, think about Bitcoin, right? If your Bitcoin goes up today, there is a very, very specific chance that it might go up tomorrow as well. Of course, in the world of Bitcoin, that rarely happens where you can try to predict something, but of course, to a certain extent, you definitely can. If something changes today, it can have an effect and a say on what happens tomorrow, just like everything around us. Now, this is a very important premise which forms to be the basis of autocorrelation, right? But there are certain important things that you have to have in mind whenever we discuss autocorrelation. Whenever we are trying to understand what is happening, the link that exists between the variable's present value and maybe its previous values, the values that are yet to be generated, this gap that exists and this generation, the link that is basically giving us relationships between a time series and a different version of the same time series is exactly what we mean by autocorrelation, right? Now, that first sentence, we had it repeated. It's the same exact sentence that I've put forth again to make sure that you guys are very clear with what it is that we're going to discuss. Now, as we already discussed, positive correlation is always represented by from the range of 0 to 1, and a negative correlation is going from 0 to -1. But whenever you say perfect, it has perfect autocorrelation in terms of perfect positive correlation, it means it's +1. Perfect negative correlation, it means it is -1. When you say perfect, it means that it has an absolute say. For every, maybe for every 1 liter that decreases in fuel, in a hypothetical situation, let's just say your vehicle goes 100 kilometers. Now, there's no vehicles that I know of that goes 100 kilometers per liter today, but let's just say, right? So you can figure out when it's perfect, you have some numerical, metrical way to actually understand and derive these relationships, right? Now, autocorrelation is a domain that is actually, it's the concept that is used widely in many domains, as I previously mentioned. It's very popularly used by technical analysts who, in the domain of finances, this is extremely popular because at the end of the day, you can try to determine how much past prices of a securities can it have on a future price, right? Based on, you can bank on the past and the current values to predict what's happening in the future values. Not only are you having a data-driven solution at the end of the day, you are also getting a path to figure out how you can predict something, some sort of a regression happening in the future. And at the same time, you're mapping relationship that exists between variables, which at the end of the day is making you have a better connection with your data and to understand your data better. And once you have a better relationship with your own data, the amount of insights you might be able to pick from it might just go tenfolds, because now you know exactly what is going on. If something changes in your data, you know what else will change, right? Think about that. I just gave you 3 or 4 of the highest benefits when it comes to autocorrelation. This is really how important this domain is, right? Fantastic. Now we can come to a section where we can slightly take a look at autocorrelation to a bit of depth. Now, when I say autocorrelation is really, really simple to understand, don't be fooled by its simplicity, because at the end of the day, autocorrelation is also a domain which is very, very, it is a concept which is very, very powerful, right? So, since we're trying to assess and analyze what's happening, we're trying to assess a link that exists between a variable's current value and its previous value. Autocorrelations can sometimes be also known as serial correlation or lagged correlation. Now, it's called lagged correlation because when you say lagging, it means something is behind, right? You're trying to take the current value, you're trying to take the past value, and you're performing as such. So there is a lag between the past value and the current value. Hence, it's called lagged correlation. And if you want to call it serial correlation, basically you're trying to assess the data in a serial and a structured manner. You're not taking two very different data points and saying, here's the past of this, here's the past of that, now find me relationships. That will not happen, right? So you're basically taking the same entity and in a different time, in a different point of time, you're trying to figure out what goes on there. That is why, whenever you hear the term autocorrelation, lagged correlation, serial correlation, understand that you are discussing the same thing, right? So this is really important for all of you all to know. Now, let me give you an example. When you say that something from the past day has an effect on the next day, this is really, really popular in the, if you're a stock trader, if you're an intraday trader or something like that, on Wall Street, as it's called. This is a very important concept. Let me tell you how. Let's just say that there is one share which gained 5% from its previous value that it closed at yesterday evening in the market, and today it opened up and it is already seeing a 5% gain. There's another share which raised 10%, But we have share number 3, which decreased by 18% because of maybe something happened in the news or something. And, there is another share which has 3% increase. There's another share number 5, which has a 10% decrease. As you can see, we have 3 shares that are increasing in value, and, we have a couple of shares which are decreasing in value. Now, what might happen is, for a fact, now as soon as I start plotting these values, right, if I just put the second value in the first place, third value in the second place, fourth value in the third place, if I just move everything cross in one place together, as you can see, this 10 goes here, 18 goes here, 3 goes here. Tomorrow's net gain or loss, when you compare it previously, at the end of the day, is basically the change that you see on your screen right now, right? So understanding autocorrelation with respect to this way, knowing that a previous gain might lead to another gain or might lead to another loss. Now, you might have very well seen that, hey, today the stock rose 5%. So there's a very good chance it might raise tomorrow as well, right? So tomorrow it will gain 10%. But there are certain cases where there is a negative correlation at hand. Today your stock went up 10% because something happened. Tomorrow again, you wake up, there's something in the news. Again, what you share, whatever it gained, it went down. It further went down your initial 10% as well, right? So this, at the end of the day, is how you would actually map it in the industry of shares and stocks and trading and whatnot. But at the end of the day, all of this is a really automated, well-structured process driven by tons of data, driven by machine learning models, driven by artificial intelligence entities in today's world. But I had to break it down to this simple sense to make sure that you guys are getting, right? This sort of serves as the foundation through which all the other concepts, the other domains, the other tools, the other techniques follow through as well. So it becomes very important for all of you all to know. Again, similar to correlation, autocorrelation also has a value which can result in between values of -1 and +1. If it is a perfect correlation, you know that it is +1. If it's a perfect negative correlation, you know it's -1. But when we say that there is a correlation, autocorrelation of +1, it means that in the time series that you had observed, that there was an increase that was seen, and the proportion at which it was increased was compared to the previous time series in hand. Now that is basically a very complex way of sentencing what I just explained to you guys in the most simple fashion, right? But yeah, that is something you have to know as well. But again, it's not always positive correlation. There are certain cases where there's negative correlation. Full negative correlation is -1. One increase in one time series will lead to a decrease in the other time series. And you have two series, one increases, other decreases. If it is positive, both will increase or both will decrease at the same time. Now, that is important. Now, there is a case where perfect positive correlation means when one entire thing increases, that is also correlation. When entire thing decreases, you can see these two entities that I have, maybe two balls that I have in my mind, two bottles or something like that. You will see that the way I probably move it will give you a lot of clarity about what's happening. One decreases, the other one increases, the other one decreases, one more increases, right? Something very similar and very simple to know. Now, autocorrelation is really, really popular in today's world because of the fact that we have the capability to plot and determine a linear relationship that exists between these variables. Now, this is possible only because of the fact that there is a non-linear link that exists between a time series and a lagged version of the same time series at hand. This is the case. Now, this is where it gets interesting. This is the case even though you might say autocorrelation is negligible. Even if autocorrelation is negligible, there is that non-linear link that exists between the time series we have right now and a lagged version of the time series, right? So I hope you guys are clear with that aspect of autocorrelation as well. Now, we had a chance to understand what is correlation, where it is used, how it works. We had a chance to look at autocorrelation, understand the range of it, understand that we can determine the relationship that exists between a time series and a lagged version of a time series. We know what positive correlation is, we know what negative correlation is, and we definitely have a good amount of understanding. But the question that you must be asking at this moment of time is, how do I test for autocorrelation? And in this section, we are going to take a look at exactly that. So coming to testing for autocorrelation, right now there is one very important method when it comes to autocorrelation. It's basically called as the Durbin-Watson method. Now, whenever you take a test number, right, it usually has a range between 0 to 4 that is produced by the Durbin-Watson test. Now, what happens here is that whenever you have values between 0 and 2, we talk overall it's 0, 1, 2, 3, 4, 0 to 4. But when you divide that in half, when you say, hey, what happens between 0 to 2? Well, Well, if you have values reported by Durbin-Watson to be 0 to 2, it means that your two variables have higher degree of positive correlation. Now, when it goes from 2 to 4, it means that it has negative correlation. Now, this is a concept which can get beginners and newbies confused. Now, in previously what we saw was if it is 0 and if it is anything with a negative number on it, it is negative correlation. Anything with a positive number, positive correlation. But here, you have to understand that 0 to 2 is positive correlation. 2 to 4 is negative correlation, right? Negative autocorrelation. Sorry. So, what happens if we are at 2 is a question you must ask. 0 to 2, great. Positive correlation. 2 to 4, negative autocorrelation. What happens at 2? Well, when it happens at 2, we say that there is, we indicate that there is negligible amount of autocorrelation that exists. If it is at 2, similarly, in our real case between -1 and 1, if we had to stop it at 0, you would know that there's negligible amount of correlation that exists. Similarly, here in autocorrelation as well, by making use of Durbin-Watson, we have a chance, we have a way to figure out how we can go about testing for all of that, right? So, when we are testing for autocorrelation, you have to understand 90% of the application goes through technical analysts and in a technical analysis scenario, right? So, whenever we are trying to analyze trends, whenever we try to see what happens next, whenever we try to find some sort of regression, find pattern, figure out with current values what happens in the future. A very simple example, that weather example I gave you, right? Predicting tomorrow's weather. It is not tomorrow yet, but we know what will be the weather tomorrow. That is, you're predicting it. You cannot say that that will happen. You can say that there is a certain chance. If you're very, very sure about it, you can say there's a 99% chance it will happen. And if you're 100% sure, you say that there is 100% chance that happens tomorrow, right? So basically, when we're trying to analyze and assess these trends, autocorrelation is primarily used in all of these because it will give you this ability to chart out things, to plot it out, and to understand what changes in which points of data, not just in which points of data, but at which points of time will lead to giving you an answer to the relationship that exists between variables and how this relationship has an effect on the objective function, on the final result that we are discussing, right? So this becomes very important for you guys to know. And again, as I just told you, right, today if there is a stock which is showing really high positive correlation for 1 or 2 days, constantly it is rising, what would your intuition at this moment of time say that you know autocorrelation? So you would definitely say, hey, if it has increased on a great level for 2 days, there's a very good chance it might. I'm not saying it will, I'm saying it might. It might rise in the next 2 days as well, right? So to understand this, to track it, to test it, we have Durbin-Watson and we have the scores. Now you know how to read and analyze the scores as well. Well, coming to the next section where we're discussing applications of autocorrelation. Well, autocorrelation, as you've probably heard for the last 30-35 minutes from my side, you know that I'm a huge fan of it and you know that it's extremely popular, right? So, it's not just IT, it's not just 1 or 2 companies that use autocorrelation. Everywhere from healthcare to any industry that you might remotely think of using autocorrelation, uses autocorrelation, right? So whenever you have to have a situation where you want to provide quantitative insight into maybe molecular level diffusion and chemical reactions in the world of chemistry, that's a very different beast of what we're talking. There, guess what? Autocorrelation plays a very, very, very important role. And whenever you are trying to, if any of you guys, try to play guitar or piano or something like that, I am a guitar instructor as well, so I teach and I play. So you have to understand that whenever you try to understand correlation that exists between, you might have heard of people saying they've used auto-tune while singing. Their actual voice will not be pitch perfect. They're not singing as per the frequency, but 1 or 2 slight, 1 or 2 hertz, 10 hertz, maybe it requires a bit of correction to get it to sound really accurate to that musical scale that you're singing in. Now, if you're not a musician and if you didn't understand anything that I said, just understand that whenever you play a musical note, it gives you a certain pitch, a certain frequency. To figure out what frequency it is, again, it's a time series on its own, right? It's a wave that moves through the air. Figure out there to understand what's happening, which signal. Whenever you're using a guitar tuner, understand autocorrelation is being used to a certain extent there as well, right? So pitch detection algorithms are very, very popularly known for autocorrelation because here you can find out what is the pitch. If the singer has to sing in the C scale, but while singing there's 1 or 2 changes that is made, you can actually change the singer's voice. Sorry, you can change the singer's voice to make sure that it is aligned very much to all the limits and the frequencies that are allowed in that particular scale. Or maybe while playing your guitar, maybe you just missed one or two slight bending of the string, and when you bend it, you're changing it linearly to another pitch. So there again, autocorrelation is very much used. If you think that was it, absolutely not. Autocorrelation is way more popular than that, because even in understanding the example that I just gave you, right, understanding how the universe around us in terms of these astrophysics concepts that I just told you, here is where it plays a very, very, very important role, because anything that we observe that is extremely far away from us, we use time as a measure, time as a metric, right? What is happening right now versus what will happen to the same star or whatever it is, maybe 10 days from now. How much does it move? It can tell us so many things. Just measuring these differences in time. First of all, when you look at the sky, you're looking at a time machine, because the farther away the object is, the older light is coming from it. So it means you're looking into the past of an object. I know I'm getting way out of hand with this astrophysics. It's an amazing concept, and I definitely suggest you guys read more about that. But again, coming back to the applications of autocorrelation, even in the domain of geosciences, geology, it is very, very popular to help us understand what is going on. There's a lot of seismic activity everywhere around the world, right? You'll be surprised to know that there are hundreds of earthquakes every day, every single day around the world. Just that some of them are pretty severe, some of them are very high on the Richter scale, and some of them are like not that great. You might maybe feel a little jerk, but that's about it, right? And sometimes it happens far away from civilization, in the middle of an ocean where the tectonic plates are there as well. So knowing that even in geology it plays a very important role is great, but what will help you understand is that when we come back to the domain of healthcare, it is used to visualize how your blood flows. Whenever you might have heard of this ultrasound treatment, ultrasound imaging and all of that, right? So when you have to visualize the blood flow and understand how the blood moves around in this medical ultraflow or imaging solution as well, guess what is used? Autocorrelation, right? Absolutely fantastic, guys. Now that we've had a chance to take a look at all these things theoretically, let me actually showcase to you guys a small demo. It's a machine learning demo through which I can show you an actual look at what happens when you have to perform, when you print something called as a correlation matrix, and how you can use the correlation to devise an entire solution, right? So guys, let me quickly open up Google Colab. Google Colab is basically a Jupyter notebook that is hosted on the Google Cloud platform. Now, as soon as I open up with that, we can get started. All right, guys. So as you can see, I've quickly opened up Google Colab here. Google Colab, again, as I just told you, is a Jupyter notebook that's on the Google Cloud platform. You can, you can basically execute Python code anywhere in your choice. I'm sure you guys might have your own local Jupyter notebooks. You guys might have your own IDs like PyCharm and whatnot. So understand that the code is usually never dependent to any of the IDs we discuss, but there is one or two snippets which is basically different from which differentiates Colab from the other different IDs out there. Now, no issues, all of that won't come into the picture, because here what we're trying to do is we're trying to quickly use machine learning to help you understand an actual use case. And in this use case, a part of this use case is where correlation comes into our picture, right? Now, guys, as I'm going to start explaining to you guys about what we're trying to do, and my goal here is to make sure you understand that devising the solution such as this is very easily done in Python, and just understand and look out the concept of correlation practically, right? Now, if you are not very well versed with Python syntax, or if you're still learning it, if you're still picking up certain concepts, do not worry. My goal is not to go each line and tell you what is happening there, but I'll give you a quick gist. We'll execute it, we'll move to the next segment, understand what is going on, and repeat the same, right? Fantastic. Now, that way you will not get confused and you get to understand the concept that we're trying to discuss here. Now, as always, whenever we discuss anything in terms of solving a problem using Python, we'll have to split it out into a couple of steps. Now, the first step, in my opinion, should always be us importing all the libraries which we're going to be using. Now, as you can see, we have multiple libraries: NumPy, Pandas, Matplotlib, Seaborns, Scalar, which is short for scikit-learn, right? NumPy stands for numerical Python. If you have to perform any any sort of numerical computations in Python, you know which library to use. And pandas is a fantastic library which provides us with two great data structures, pandas series and pandas data frames. We have matplotlib and seaborn. Matplotlib and seaborn are two data visualization libraries which are amazing to work with. And then we have sklearn. Sklearn is like the heart of machine learning when it comes to Python, right? Now, executing code in Collab is very simple. All I have to do is press this play button, and as soon as it gives me that tick mark, it is actually done executing. Right now, all of our libraries are imported. The next thing is, since you're working on a dataset based solution, we have to import the dataset. Right now, as soon as I click this button, it'll actually give me an error. It'll tell me, hey, where is the dataset? Now, the dataset is actually in my local computer, but I am working on the Google Cloud platform. So let me quickly upload it from my machine to the Google Cloud platform. As you can see, it's already done. Now again, when I execute this, is basically it has access to the data set. It knows where the data set is, so it can import it. As you can see, no errors, imported. Now let's take a look at the data set. Let's quickly print out the first 5 rows. Now there's a lot of rows in this data set. I'm just printing the first 5 for you for convenience, right? Now, as I just told you, we are trying to figure out if a person has diabetes or not. We have hundreds of patients worth of data. Every single row that you see here is basically, one row is one patient's worth of data. You can figure out the number of times that person was pregnant. You can find out their blood glucose level, blood pressure level, skin thickness level, body mass index. Body mass index, I'm sure you must know, right? I think the average value should be somewhere around 25 if you're fit. Less than 25, it's like you're either anemic or malnutrition or something like that. And anything about 25 or anything about 30, I think it seems that it's slightly obese, very obese, and out of hand, so something like that, right? So 25, I think, in my opinion, is like the standard value that's out there. And of course, age is going to be a very big age is probably going to play a very big role in the outcome as well. Right now, outcome, you might be confused. What am I saying? Well, wherever it says 1, it means we know for sure this person is diabetic. Wherever it says 0, we know for sure that this person is not diabetic. So if we have all the data at hand, why are we even performing any analysis? Here's a fun fact. Now what I'm going to do is this last column that's out there, I'm going to remove that entire column out and basically just provide everything else to my machine learning algorithm. And I'm going to say, hey, here is the details of pregnancies, glucose, blood pressure, skin thickness, insulin, BMI. You have everything you want to learn. Learn and understand what causes diabetes and try to predict, if you can, about if someone has diabetes or not based on all these values, right? Not the last column. The last column we already know. If we provide that, it's like cheating in the machine learning algorithm. We're not going to let the algorithm cheat here. We're going to make sure it learns actually, right? So as you can see, now just looking at it, you or me cannot definitely say what has the highest say. Can I say that glucose is the reason why you get diabetes? Can I say blood pressure is the only reason why you get diabetes? Or can I say there's a 30% chance that insulin is causing you diabetes? Maybe, but right now it's all speculation until you prove it with respect to data, right? Now to give you a little bit more about the idea about data set, as you can see, I just ran one line of code from that time, which is running one single line of code. And here you must be asking a question at the moment saying, okay, you just showed us the data of 5 patients. How many patients do we even have? As you can see, we have 768 patients worth of data in detail. So let's quickly try to understand it from a statistical perspective. As you can see, wherever it says count, it basically means the number of values that are present. And for each of these, of course, we have 768 patients and we have 768 entries in each of these columns. If it was less, it means that there is a blank entry in mine. Mean is basically giving us the average. You can find out the average glucose value, average blood pressure value, average body mass index value, average age of your data set and whatnot. Right? And then there's standard deviation, there's minimum value, and then comes the quartile value, right? So minimum, basically you can divide your data into 4 quartiles, Q1, Q2, Q3, Q4. Minimum to 25% is Q1, 25% to 50 is 50th percentile is Q2, 50th percentile to 70th percentile is Q3, 75 to max is your 4th quartile. Now, if you do not know what quartile is or interquartile range or anything as such, absolutely do not worry. If you quickly want a statistical look at your data set, all you do is use the .describe method and it gives you this analysis. Now, looking at this, if you just wanted the average of everything, one line of command, you have everything at hand that is needed, right? Now, the next step in the way is where we check for NaN values. Now, when I say NaN, it stands for not a number. I'll give you an example. I'll quickly go up and show you this. Now, if I say, hey, if I just ask the patients to just give them a sheet or something and tell them to give us details about each of these columns, instead of glucose, it has to be a number, right? Blood pressure, it has to be a number. Age, it has to be a number. Instead of a number, a person might write something else. It can be user error. Instead of age, the person might have written his blood group, O positive. Right? Now, when you see things such as that, for us, it's like, oh, it's a small error, let's correct it. But for your machine learning algorithm, it can be devastating, right? It can actually lead to the accuracy crashing a lot. So what we're trying to do here with this piece of code is trying to figure out if we have any character values where in the places where we're supposed to have numerical values. If any of these were to say true, that is when we understand that there is no numerical value there is a character value, and we have to fix it really quickly. Now, as you can see, my data set is already clean and we have all the data which is in its correct format right now. So no need to perform any pre-processing. And this is where this, as you can probably see, it's a very simple piece of code. But this is where all the actual magic in terms of correlation happens. Now, let me quickly zoom out to 100% to show you what it looks like. I'm very sure you might not be able to read anything that you see on your screen because it just becomes extremely tiny. But everything you see here, right? All these each colored square blocks, it's in the form of a square matrix. Each of this is basically giving us a correlation between another variable. Now, as you can see, it has a legend. When I say a legend, it basically is giving us a way of understanding what is going on. If it is 0, it means that there is no correlation. If it is very dark, you can see there are a couple of dark blocks. As and when it gets lighter and lighter and lighter, it has a lot of correlation, right? So the darkest one is black. The lightest one is white. You might be wondering why it is white, right? So let me just tell you here, consider this, pregnancies. Now, if you have to compare pregnancies with something else, that is when you will realize that there is some sort of relationship that exists. But what if you take pregnancies and compare it with pregnancies? Don't you think it's exactly 100% the same for that exact patient? Think about glucose. If you're comparing glucose with glucose, it's exactly the same. If you're comparing glucose with pregnancies, you see that it's a slightly different color. There's some sort of correlation here. And you can also figure this out for the rest of the columns in the diagonal, right? Everywhere where it's a diagonal, you're comparing the exact same thing to the exact same thing. So there's always going to be 100% positive correlation. Now, wherever it is black, see, pregnancies and skin thickness is black. So apparently in our data set, these two values do not have any great correlation. Now let's pick up a light color. Here's a light color, insulin and skin thickness, right? You can see that insulin and skin thickness have some positive correlation. So maybe an increase in insulin leads to an increase in your skin thickness or something like that in the medical term. But as you can figure out, right, looking at these various square blocks having different colors, you can actually sit and map and understand. In fact, here you can print out an entire chart to figure out what variable has what sort of relationship with respect to your outcome, right? Now, as you can see, the outcome here, it says 0.46x. This is the highest number that you can see on screen. And guess what has the highest say in you actually having an outcome of maybe having diabetes or not having diabetes, right? Look at that. So I can just take a look at it. I can guess, even at this moment I'm guessing, but I can definitely say glucose has the highest percentage of say in terms of a person having diabetes or not. But you're comparing a point to your outcome. You can actually compare one point to another one, which is exactly what we did right now. And this way of understanding, taking a look at it. Now, I'm just basically giving you a guide on how you can read and understand what's going on here. But at the end of the day, if you can figure out what each of these does and just derive solutions out of them. If you say, hey, okay, so if glucose is high, it means insulin can be high as well. You can actually make a note out of it, and you can actually use that for your further studies, and you can figure out what changes in each of these will affect your outcome. That has to be the biggest advantage, right? Fantastic. Now, that is the correlation part of it. From here on, it's all machine learning. So let me quickly walk you through what happens. The first question you must ask me is, hey, we have 768 people. How many people have no diabetes? Well, 500 people do not have diabetes, and it's basically a simple code. Now, how did I print this out? All I had to do was go up to my data set. Figure out how many ones are there. All I had to do was count the total number of ones present, and that gave me a number 500, which is telling me that 500 people have diabetes. Now, the rest are going to be 0, of course. It means 268 people have no diabetes. Now, to make sure you guys understand this really, really nicely, Here is a beautiful looking graph that showcased to you guys. Now, wherever is 0, it means the person has no diabetes. Wherever it's 1, it means the person has diabetes. And you can see from the list that if it says 500, it means that 500 people don't have it. And if it here it's somewhere around 268, right? So somewhere around that, and you can quickly look at this. You don't have to run 10 lines of code. You can look at this and figure out what's going on with your data. Now, in the case of machine learning, as I told you, if you just provide the outcome to your machine learning algorithm, it'll not be of any learning because it already knows what is happening. Just like you using your textbook in your examination doesn't work. It's not testing your knowledge, right? So look at this first line. What we're trying to do is we're taking that outcome column, throwing it out the way, removing it to make sure our machine learning algorithm actually learns. Then we take our entire data set, we split it for training and testing data set. 80% of the data is used for training, 20% of the data is used for later testing. Now we're going to be using one regression method called logistic regression, which is very, very popular, very famous. The actual process of machine learning, if you're first time looking at Python code, or if you're a person who's looking at a machine learning code for the first time, understand that we had to do all of these or almost all of these to teach our machine learning algorithm, and the actual teaching happens in one line. This is the actual line. The process is basically called model fitting, where you're fitting your model, where you're getting your model to understand everything over the training data by using your regression function or your regressor. Now, as soon as I hit play, it's going to give me a small warning probably. Yes, as you can see, it says there's total number of iterations. Basically, it finished its total number of iterations in terms of learning. You understand that it's a repetitive process, right? And then coming to the last step is basically us trying to perform predictions. We are testing to see if our machine learning algorithm learned anything. If you guys are statistics heads, you can understand what this is. It is basically a confusion matrix. If you do not know what this is, it is actually us trying to understand the various measures of accuracy. Now, the 4 values that you see on your screen are true positive, true negative, false positive, false negative, and each of those values, as soon as you look at a confusion matrix, or as soon as I look at a confusion matrix, all you have to do is you have to tell me what problem you're trying to solve, how you've solved it, give me the confusion matrix, keep all the code, and I can tell you how well your machine learning algorithm has performed or not. Because there are certain cases where a person is actually diabetic, your machine learning model would have considered him as non-diabetic. Similarly, if a person is non-diabetic, it would have told him that he is diabetic, and eventually a non-diabetic person is now taking diabetic medicine. Very bad for your health, right? So you can figure out all of these stuff just by looking at those 4 numbers, considering what is the actual case that was supposed to happen, what did your machine learning algorithm predict, and whatnot. Now, I know for a fact that some of you all might not be able to read a confusion matrix, so here is another solution which everyone can understand. At the end of the day, you're running a machine learning algorithm. You will ask me a question saying, hey Anirudh, what is the level of accuracy that your machine learning model is working at? And as you can see from your screen, we are at almost 75% accuracy. So what that means is that for every 100 patients that our machine learning algorithm gets to learn and understand about, it can predict perfectly for 75% of them. So out of 100 patients, it can predict accurately for about 75 patients. Of course, now you might be saying, hey, it's only 75. Can't we go up to 90, 95? We definitely can. But the point here is to showcase to you guys all about correlation, all about autocorrelation, helping you understand that 2 things at 2 different points of time can lead to a certain change, which you can use to analyze and later have decisions completely driven based upon that, right? So how cool is that? Now, we didn't take a lot of code to actually go on to do this, right? All of this is just importing code. Everywhere that you see here, it's one line of code. Here we have a couple of lines of code because we have to figure out how big and what plot to print. And this is where the logic of people having no diabetes and diabetes comes in. Again, printing that entire chart is 2 lines of code. Splitting your training and testing data sets, another 2 lines of code. Actually using logistic regression to understand that you have to use that regressor to train it to perform predictions, 3 lines of code. Final accuracy prediction. Again, you can basically also do this in a single line of code as well. So all in all, where are we at? 25 lines of code, and you can see that we have done a lot with just 25 lines of code, right? So ladies and gentlemen, this is the magic of correlation. And as you saw, correlation was not the entire thing which led us to the solution, but correlation was a critical part for us to perform some in-depth analysis, which can not only tell us more about the data, but also take us closer to the solution in a more efficient manner. That is where all the advantage lies in, right? So guys, with this, we have come to the end of the course. Thank you so much for watching. I hope you are clear with everything that we have covered in this course today. We started this one out by going right to the very basics of understanding what correlation is. We understood where it is used, how it works, why it is so important, and why is it so critical for us to learn it. After that, we took a look at understanding autocorrelation. We took a couple of beautiful examples to figure out correlation. We understood time series and all that. And after that, we had a deep dive into understanding autocorrelation. We figured out not only how we can go on to work with autocorrelation, but also we had a section where we could test, we could figure out how to test for autocorrelation as well. Now, after that, we made sure to take a look at some really fascinating applications of autocorrelation, which you might have not thought about. And again, throughout the theoretical aspect of all of our discussions, I made sure to give you guys a lot of examples to make sure you understand all of these things. And to add on to all of those theoretical concepts that we just learned, I showed you a quick demo wherein in a small part of it, correlation still holds a very prominent figure in the big domain of something such as machine learning, right? So guys, with this, we have come to the end of the course. Thank you so much for watching. My name is Derive, and I'll see you on the next one.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.